Hi everybody, welcome to your first video for chapter 2 and your video for section 2.1.1, which is called What is a Relationship? Before I start the video, or before I start actually diving in to the topic, I just want to say that all of your guys' group tests were awesome. They are on Progress Book, ready for you. If you have any questions about those, please let me know. I shall be passing them out tomorrow in class. So I'm still waiting on one group to take it, but other than that, I will pass them out tomorrow in class. So we are starting a new chapter. We are starting chapter 2, which is all about angle measures. Which is all about angles and measures. So it's all about angles and measurements. So in this chapter, you will deepen your understanding of the relationship between pairs of angles formed by transversals and the angles in the triangle, how to find the area and perimeter of triangles, parallelograms, and trapezoids, the relationship among the three side lengths of a right triangle, which is aka the Pythagorean theorem, and how to determine when the lengths of three segments can and cannot form a triangle. So that's kind of a quick summary of what chapter 2 is going to entail. And then what you should know by the end of section 2.1.1 is an introduction. So you guys will start with an introduction to a problem with mirror reflection. So you guys have talked about mirror reflection before. We're going to see that again. Which is going to help motivate your guys' work for 2.1. Then you will learn how to name angles, and you will learn the three main relationships for angle measures, which would be supplementary, complementary, and the same, so if they have the same measure. Students will also discover the vertical angles have the same measure. So this is all stuff we're going to talk about, you guys are going to discover, you guys are going to work with in this chapter. So when you guys come into class, you guys will start with problem 2.1, which, like we talked about, is that mirror hinge problem. You guys are just going to basically talk about this problem. So I'll give you guys 5 minutes at the beginning of class just to work through the hinge problem. You guys will talk about those 3 questions. You don't really have to write anything down unless there's really any big main ideas that you guys have. But that's just a discovery activity to get you guys started with what we are actually going to be talking about. Then you'll go into 2.2 and talk about the 3 problems there. You'll go into 2.3, which is when we get into our definitions and our 3 main angles. And then you move on to question 2.4. So you'll have about 25 minutes to work through those 3 questions. Then question 2.5, we are going to be doing part C and D in this video, and then you guys will be doing A and B as part of your exit ticket to make sure you guys are understanding what's going on. And then you guys have your methods and meaning box, which we'll talk about in this video. And then you guys will actually be doing 2.A part C as part of your exit ticket, as well as 211 as part of your exit ticket. So I know that a lot of this homework, if you're looking at it, is mostly review from the last chapter. The reason that they do that is because they know that you guys haven't taken your test yet. The way that they set CPM up is you guys take your team test, and then a week later you take your individual test. So that way you guys can continue to practice the ideas you guys have learned already. So if chapter 1 is something you're really still struggling with, I would definitely suggest going over question 2.9, 210, and 212 just for practice. So if it's something you're still really struggling on, or you just want a little bit more review practice, definitely visit those questions when you have time, just even if it's just reading them and, hey, yes, I know what's going on, I understand those. But other than that, I think that 211 is really important because it talks about reflection symmetry, which is one of the last topics we hit. And I think that 2.8 is something that we're going to see more of in next section, so that's why I want to hit that problem. So we are going to go ahead and start with our notes here, which we are going to start with vocabulary. So this is also in your book if you need to refer back to it. But what we talk about today, the 2 big definitions we're going to talk about is complementary angles and supplementary angles. So complementary angles are 2 angle measures that add up to 90 degrees. And then supplementary angles are 2 angles that add up to 180 degrees. So when I was in high school, I don't know why, but I felt like I really struggled with remembering which one was which. So for me, I came up with this whole idea that 90 comes before 180 and C comes before S in the alphabet. So I know that complementary goes with 90 and 180 goes with supplementary because C comes before S and 90 comes before 180. So I know that that's not a great way to remember it, but it's worked for me. If you come up with any other great ideas of how to remember that, I'd love to hear it. So let's go ahead and jump into question 1 or example 1 here. I do suggest writing this down in your notes just so you can always come back to it. And if you write it down, you're going to remember it, you're going to practice it. Maybe even stop the video and try question C and D on your own because you've actually seen question C before. You've seen something like that, not only on a homework, but also on a homework quiz. So just make sure, maybe pause the video for a couple minutes, try and run through that, and make sure that you know what's going on. And you can do those 2 problems by yourself because that's a really important topic. So if you want to take a couple seconds, pause it. If not, that's okay. I suggest you do, but whatever works for you. So what we are going to be doing is finding angle DBC. One thing that's going to help you guys a lot is highlighting what they're asking you to find. A lot of times geometry gets confusing because you're asked to find so many different things or they throw so many different letters at you. So when we're finding this, you're finding angle DBC. So that's our big guy right there. It's what we want to find. So when I was going through this, there's a couple different ways you could do this, but this is just the way that made most sense to me. I am going to take 2x minus 4 and x plus 7 and set them both equal to 90. So that way I can find what my x is, and then I'm going to take my x once I find it and add 7 to it. That to me just made the most sense. You could take 90 minus 2x minus 4 and set that equal to x plus 7. Lots of different ways you could do this. So we are going to start by setting 2x minus 4 plus x plus 7 equal to 90. So that way we can go ahead and find what our x is. We can start to solve this equation by combining like terms. So if you have 2x plus an x, you have 3x. And then when you have negative 4 plus 7, you're going to have a positive 3 equals 90. Remember, we need to get x by itself, so we are going to start by subtracting that 3. So we are going to have 3x equals 87. And then we are going to take 87 and divide it by 3. So x is going to equal 29. Be very careful, especially on the state test. I know I refer back to that a lot, but that's like our big goal for the end of the year. They will probably put 29 as an answer for multiple choice. Okay, so that's why I always said be very, very clear on what you're looking for here. So we are actually looking for angle DBC, which is not 29, but it is 29 plus 7. So what we want to do is take 29 plus 7, and that's going to give us 36 as our answer. So 36 degrees there for our answer. You can always go back and double check your work by plugging x in for both of those angles, adding those angles up, and making sure that they equal 90 degrees. So that was the first question. The next one asks us to find LPQ. So LPQ and LPN. So a theorem that we are going to be working with and we are going to be studying and you guys are going to get a little insight on in this lesson is that the angle that I highlighted in pink is also equivalent to NPM. So those two angles are equal. They're congruent. So that angle is equal to this angle. And then angle X, this X measure is actually the same as this guy right here. So I could put an X there too because they are the same. Alrighty, and they actually talk about that. If you go up right here. So it's called the vertical angle relationship. So vertical angles have equal measures. So if you're looking at this picture right here, B and C are going to have equal measures right there. Alrighty. So if we're looking at this, x plus 28 plus x is going to get us 180. That needs to equal 180 because this is a straight line. So that means those two angles have to equal 180. So all I'm going to do is x plus 28 plus x equals 180 degrees. So I'm going to combine like terms like always and have 2x plus 28 equals 180. So I need to get 2x by itself, so I'm going to take 180 and subtract 28 from it, and I get 2x equals 152. And then I'm going to go ahead and divide by 2, which x is going to equal 76. So my measure of LPN is going to be equal to 76 because it's just x. My angle measure for LPQ is going to be my 76 plus 28, which is going to give me 104. Now take a couple seconds and think about how you could double check your work here. Just take 10 seconds and think how you could double check your work. Alrighty, if you said add 76 plus 104 equals 180, double check that that's an accurate statement, you would be correct. So that's how you go back and double check your work there. All right, so those are our two main examples, our two main topics for this lesson, but I do want to go over two review problems. The first one being question 12 from what would be your homework. So Larry saw Javon's incomplete Venn diagram below and he wants to finish it. However, he does not know the conditions that each circle represents. Find a possible label for each circle and place two more shapes into the Venn diagram. So what I was thinking for this is that this side probably has to be that all sides are equal. Because that's what that square and that that triangle have in common. So the square and the rectangle, they have that in common. But what is different from the square and the rectangle? And that would be that the square is a quadrilateral. So just making sure that we are all familiar with the definition of quadrilateral, that has four sides. So it just says, and place two more shapes in the Venn diagram. So we could place a rectangle over here, because that's a quadrilateral. And then we could place a regular hexagon in here. And I know that doesn't look like all sides are the same, but the definition of that says they are. So you could put anything in there that all sides are equal, and on the other side you could put anything that is a quadrilateral for that guy. Alrighty, then we move down to 2-9. No idea what that name is. I'm going to assume it's I don't know. Puts the shapes below into a bucket and asks Brian to pick one out. What is the probability that it pulls out a quadrilateral with parallel sides? So you have seen a lot of questions with probability and shapes, which means you're probably going to get a question like this on your individual test. So definitely make sure, maybe pause the video, make sure you know what's going on here. And 100% you know how to do that, because I'm telling you right now, this will be a question on your individual test. So what is the probability that pulls out a quadrilateral with parallel sides? So we're looking for a four-sided figure with parallel sides. We got 1, 2, 3. So we got 3 out of 6, which is equivalent to 1/2. I'm okay if you give me it as a fraction. Just know that on the state test, it could give you anything from a fraction to a decimal to a percent. So obviously 1/2 is just 50%. All right, what is the probability that pulls out a shape with rotation symmetry? All right, so since it doesn't tell me what type of rotation symmetry, I can assume it's almost anything except for 360 because every single shape has rotation symmetry. So let me just erase that here. We know that the square has rotation symmetry. We could rotate that 90, 180, 270, 360. We know that this triangle has rotation symmetry. All you have to do is take 360 divided by 3, and that's how long it's going to take to get back there. We know that the kite has rotation symmetry. We know that the parallelogram has rotation symmetry. The only two objects that do not have rotation symmetry are going to be the scalene right triangle and the trapezoid, because those ones only have 360 rotational symmetry. If I gave you something with this question, rotation symmetry, I'd probably give a specific what has 180 rotation symmetry, what has 90 rotation symmetry. I wouldn't just leave it blank like that. But for this one, we assume that it's anything that doesn't have 360 because every object is going to have 360. So for this one, it would be 4 over 6, which is 2/3, which is 66%. Oh no. Alrighty, so now that we've gone through our first chapter and we have done our first team test, this is probably going to be more of the format for these videos. Is we'll go over some homework problems, we'll go over some review problems. There'll be more review problems on your exit ticket with probably one problem of news material, and then we'll go over some vocab and what you guys are to expect for this chapter. So I apologize that this video is a little bit longer. I just had to introduce chapter 2, and I will be posting your guys' video for tomorrow night, so you guys can watch that tomorrow after class. But other than that, enjoy the rest of your Sunday night, and I will see you guys tomorrow in school.